Okay, now let us take another problem which says let f be a function from R to R where it is defined by that it is k minus 2x for x less than minus 1 and it is 2x plus 3 if x is greater than minus half. So now what you have to do is you have to find f has a local, it is given that f has a local maxima at x equal to minus 1, then you have to find a possible value of k. Okay, so see, this is a very easy problem. You don't have to do anything in it. It's just basically you can solve it by putting values. Let me write down the the function that is given to you. First of all, it is k minus 2x if x is less than minus 1, less than or equal to minus 1, and it is 2x plus 3 if x is greater than minus 1. Alright, so if it has, let's suppose it says that it has to be local maxima or minimum at x equal to minus 1. So if this has to be the condition, then the value at the, let's first of all think about what is local minima. If this is x equal to minus 1, then the values to the right of this should be greater than the value at x equal to minus 1, and the values to the left of x equal to minus 1 should also be greater than the value at x equal to minus 1. This is what you mean by local minima. So the value which will be just to lying towards the right of x equal to minus 1 would be, if I put x equal to minus 1 in this one, what I'll get? I'll get x equal to, let's see, if I put x equal to minus 1, that implies y will become in this equation only, though x equal to minus 1 does not satisfy this, but still we are doing it. Let's see y. So first of all, finding the value of y, it will give us the value as 1. Alright, so the value comes out to be 1. Or if I draw the graph, let's say, if I draw the graph, the line 2x plus 3 would be something like this. Alright, and where this point, I can say this point would be minus 1 comma 1. This point would be minus 1 comma 1. Now I have to draw y equal to k minus 2x in such a fashion that the value at this point, which is this should be smaller than this one, because at x equal to minus 1, this is x equal to minus 1, the value should be from this function, not from this line. Alright, so now just start putting the values of k. A very simple question. If I put k equal to 0 over here, that implies y equal to minus 2x. Alright, if y equal to minus 2x, then at x equal to minus 1, the value of y will be 2, which will be here. So it cannot be local minima because why? Let's see. Now if this is the point, then this cannot be local minima because just to the right of it, that is at x equal to, you say, let's say minus 0.9. Alright, the value will be something here. Alright, so that means it is still smaller than this value, so it cannot be a local minima. So this is rejected. So option A is not correct. Okay, let me erase this thing out now. Alright, now let us take the other value. Okay, now let us take the other values, which is basically k equal to minus half. So if I take k equal to minus half now, that implies what will be the value of the function now? The value of the function would be minus half minus 2x. And at x equal to minus half, what this value will become? This will be y is equal to minus half plus 2, that will be 3 by 2. Now if I draw 3 by 2, again 3 by 2 will be above this 1. Alright, and this, according to the same logic, this point is also rejected because we need a value which is less than this point or at the max equal to this point. Alright, so now let us take the third option, which says k equal to minus 1. Here the function will become y equal to minus 1 minus 2x, and again if I put x equal to minus half, the value that will come out to be, the y will be equal to, now y will be equal to what? 1. Alright, now okay, if y is coming out to be 1, that means it is this point. Alright, so this is a possible case we can check forward to. Alright, but let's suppose, let's see the third option first of all. If k is equal to 1, that implies, so y will be equal to 1 minus 2x, and at x equal to minus half, the value will become y equal to 3. Y equal to 3 is way beyond 1. It will be here. So this point again cannot be the local minimum. So again this point is cancelled out, so the only option left is the C option, which is the correct option. So you can see this was a very easy problem. Nothing, we have done nothing in this. We just put in the values which were given in the option. Okay, we have not solved anything for the equations and all. So no application of derivative being used. It's a simple plain question just by putting the options here. Okay.